So today I'm going to be working on this model 1883 Waltham. I've already inspected it, and what I have found is it's got a broken pallet fork pivot, it's got a broken balance jewel, the roller table on the balance staff is glued to the balance staff, it's missing the setting wheel spring, it's got the wrong screw in the setting wheel spring location, it's missing the second hand, and the setting wheel mount is bent. One of the items that needs to be dealt with on this movement is, for some reason, someone in the past used some type of mystery adhesive that looks like shellac to glue the roller table to the balance staff. First step is to measure the balance staff where the roller table fits up to see if it's the correct dimensions. And it measures out to the correct dimensions. The hole in the roller table may be oversized. I'm not sure why they've used adhesive. The adhesive on the balance staff is preventing the roller table from seating against the hub where it needs to be. Time to remove the mystery adhesive and then do another fit test. I'll remove the hairspring so it doesn't get damaged during the cleaning process. I'm going to soak the balance in denatured alcohol. If the mystery adhesive is shellac, it will dissolve in a couple of minutes. After 5 minutes, the adhesive is still there, so it's definitely not shellac. I have no clue as to what this stuff is, and I don't want to subject the balance wheel to a bunch of test solvents, so I'll remove it mechanically by slowly chipping it off a piece at a time. Now, with most of it removed, I'll finish it up with a fiberglass cleaning brush. The pallet fork had a broken pivot to deal with. Rather than repivot it, I decided to remove the old shaft and fabricate a new one. I used the staff and pivot wire and cut one to size on my lathe. Before it was pressed in place, the following fit checks had to be taken. This was to make sure it had correct end-shake clearance. If it has too much end-shake, it could end up contacting roller table assembly and affecting the timing during dial-up or dial-down positions. It needs to be inspected with the backplate secured in place with all 3 pillar screws tight. Looks perfect. About 1/1000th of an inch movement. Should function same or better than original. Now it's time to press the shaft into the pallet fork assembly. To press the shaft in, I'll use a staking tool and lightly tap it into place. Time to do a fit check of the pallet fork. I'll need to adjust the pallet fork so that the pallet jewels are centered on the escape wheel teeth. Once that's done, I'll check to see how the pallet fork meshes with the balance wheel roller table. All the train wheels installed. Some light pressure on the third wheel to check to see if the pallet jewels lock into position while meshing with the escape wheel. A slight nudge with the tweezers on the pallet fork, and it can be seen to swing back and forth in the two locking positions. I'll continue to do this until the escape wheel teeth have cycled through the pallet fork jewels. If they don't lock correctly, they will need to be adjusted. And they lock perfectly, so it's time to move to the next item. The roller table has a snug fit, just as it seats next to the balance staff shoulder. They usually have a bit snugger fit, must be why someone put some adhesive on it. The diameter on the shaft measures out to factory dimensions, so any looseness in fit must be in the diameter of the hole on the roller table. I'm going to do a fit check to see how the roller table fits with the pallet fork. The fit looks good. Put some manual pressure on the third wheel, and the balance wheel performs great with the new pallet fork shaft in position. One of the balance staff jewels is damaged, so need to see if I have a replacement in my stock. Great, I have a dozen 18 size ruby staff jewels made for American watches. This one will fit once the OD is turned down about 1/1000th of an inch. With a jewel collet, I can mount the jewel and dress the OD to a snug fit into its seat. They have a depth adjusting screw on the back of them to make fine adjustments. This could also be done using a faceplate and shellac to hold the jewel in place. I've removed a small amount of material on the OD of the jewel setting, and it's now time to do a test fit. The in shake is perfect. This should do just fine while in service. The mainspring looks to be new, virtually no wear on it. Looks like someone installed a new mainspring in the past and the watch wasn't used. The end shaft on the mainspring arbor has two flat spots with burrs that are sticking up. Looks like someone in the past put a pair of pliers or mounted it in the vise for some reason. I'll mount it in the lathe and polish the burrs off. Okay, that looks much better. Disassemble the balance cock jewels so movement can be run through the cleaning machine. Everything will fit in the cleaning basket. I'm not going to use the ultrasonic cleaner because of the risk of damaging the gold gilt. The gold gilt has survived over 100 years on some of these movements, and in my opinion, it's not worth the risk of damaging it. I've seen people take household abrasive cleaners and even steel wool to gold gilt, watch and clock movements. They come out nice and shiny, but in a short time, a few weeks down the road, the unprotected exposed brass tarnishes and the movements at this stage have been permanently degraded. Time to remove the parts from the basket. Parts all came out looking good. One nice thing about this movement is all parts have matching serial numbers. Many times mismatched parts show up on a movement this old. Time to assemble the pieces and see how it runs. The click spring, always want to keep pressure on these from the top. They have a tendency to jump out of the recess, and they can jump quite far at times. The fastener for the click spring. Turn this movement over. The yoke spring. These come in many configurations. They're used for the winding and setting the time part of the mechanism. The fasteners for the yoke spring. The winding pinion and setting wheel assembly. This mechanism operates much more smoothly now that it's cleaned and lubricated. The third wheel, the center wheel, the fourth wheel, escape wheel, pallet lever, the back plate. A little difficult to install these full plate movements because the pallet lever needs to be on top where the balance roller table fits. With all the pivots in place, it's time to install the 3 fasteners. I always make sure the back plate is nested tight against the pillars before any stress is applied to the screws. If this step is bypassed, there's a risk of damaging jewels or breaking pivots. A fit check to make sure all gears are engaging and the pallet fork is functioning before the screws are snugged down. Mainspring is installed and oiled, so now just need to install the mainspring arbor and barrel end cap. Some even pressure using a piece of pithwood and the cap will snap into place. Some oil on the mainspring arbor before it's installed. Mainspring bridge. Ratchet wheel cover. Balance wheel lower plate jewel. One drop of oil on center of balance wheel cap jewel is all that is needed. Now I'll oil the center wheel where the cannon pinion covers it. Oil on all the train wheel pivots. Now to install the jewels on the balance cock. And again, one small drop of oil on the capstone just before it's dropped into place. Loosen the balance spring stud screw and install the balance wheel assembly. With any luck, it will take off and run. The balance wheel has excellent movement. I'll set this movement aside and clean the cracks on the dial. On these porcelain dials, when they have cracks in them, the cracks will turn black. The black is either from surface dirt getting rubbed into them or from the copper in the underlying dial pan corroding. Once a crack develops, moisture and oxygen can pass through the crack and contact the copper. This will usually result in the copper corroding, and a green copper oxide will appear in the crack. Anything that will clean copper oxide will work to whiten the hairline cracks in a porcelain dial. First, you need to determine if all the black markings are under the glass glaze. Sometimes there are secondary logos put on after the dial has been fabricated that need to be considered. You don't want to remove any of these if they are on top of the porcelain. I'm going to use some oxalic acid on the dial to leach out the copper oxide locked in the hairline cracks. Acetic acid, citric acid, and oxalic acids are among the best I have found for removing copper oxide from these dials. When this watch came to me, it was missing the setting spring, so I haven't been able to test the hand setting function until now. For a replacement, I was able to find an original setting spring, and it's now time to install it. I'm now finding the setting spring screw that came with this watch is the incorrect screw. The original spring that I found just happened to have the original setting spring screw, so I'll replace that as well. We'll fasten the yoke and hope for the best. The minute wheel, the hour wheel. Now to see how the setting spring works out. Not looking good. The setting wheel isn't engaging with the minute wheel. The intermediate winding wheel is engaging with the ratchet wheel just fine. The setting spring looks as if it's shaped correctly. Installing the setting wheel, I now see what the problem is. The brass shaft for the setting wheel is bent. It will either need to be bent back, so it's at a 90-degree angle with the surface of the watch plate, or it will need to be replaced. I'll attempt to bend it where it needs to be with a hollow punch from my staking tool set. It won't take much, but then brass can sometimes be brittle. Good, it's where it should be. Now assemble it again and see if the wheels engage with each other. The intermediate winding gear, the setting spring, the setting wheel, the yoke, it's working excellent. On to the next item. When this watch came to me, it was also missing the second hand. I ordered a new old stock second hand and we'll see how it fits. It's going to need broaching out before it's going to seat on the pivot. I'll need to select a brooch that will work. These are fairly small brooches and are tapered to the size of almost a human hair. They're very fragile and work great for enlarging holes for second hands. This one fits the hand just great. The second hand is very small, and so need to use a watch hand broaching holder. This one is a spring-loaded one. It's good for securing small parts like a second hand so they can be broached. We'll get this second hand off the brooch. Mount it in the hand broaching holder. Screw the handle down to lock the hand in tight. Now a brooch holder to hold the brooch while broaching the hand. The end is so small it's like threading a needle. Brooches of this size are fairly flexible, and it's a matter of rotating it and applying very little pressure, and you can feel it start cutting. Good, it fits perfect. Now to check its fit with the dial on. I'm going to put the movement in the watch case. The porcelain dial is too thick for the second hand. Not enough clearance between the hand and the dial. And the bow is loose and needs to be adjusted. I can do that with a pair of bow pliers. It doesn't take much, and these bows can be snugged where they should be. Much better. The porcelain dial is too thick for the second hand. It'll need to be modified for this watch. Not a problem. I'll need to cut the brass center mount off and fabricate a new one that is longer. First item is to measure the shaft it mounts to and find a pivot drill slightly smaller. It's going to be a small pivot drill. I'll pull a couple out and take some measurements. Here's one that'll work. And it fits the inside diameter of the brass center hand mount just right. Now to check the outside diameter of the brass center mount and find some brass rod stock the same size. Here's some brass rod that will work fine. This one measures slightly large and will work good. Mount the brass rod in a collet. And mount the second hand in a collet so that it can be cut off. Now I can cut the hand free of the center mount. Nice. The hand is cut free. Now I can fabricate a custom center mount for it. Now that the hand is mounted on the new center mount, the rivet end will need to be rolled over. I use an old record player needle for part of this operation. This will lock the hand to the center mount. The finished hand looks good. It fits the pivot nice and snug. No broaching will be needed. The balance wheel seems to not have any power on it. Looks like something is wrong with the mainspring. It's not winding with any resistance. I'll need to pull the mainspring barrel and see what's going on with it. The mainspring barrel doesn't have any resistance at all. Not a good thing. Well, looks like the mainspring decided to fail overnight. Time for a new mainspring. A quick check of this mainspring, and I see it's actually not the correct one. The width should be 21 on the Denison standard, and this one is only at 20. That's 1/10 of a millimeter too narrow. Someone put the wrong mainspring in this watch. I have an old Waltham publication that shows correct factory size. and part number required for this watch. Here we see model 1883, barrel depth, width of spring in centimeters, thickness of spring in centimeters, length of spring in inches, and the Waltham factory assigned part number of the correct spring. Not sure of the date of this publication, but it doesn't use the Denison standard. The Denison standard has been around since the 1840s, but it looks like Waltham wasn't using it in their publications. So time to look through my pocket watch mainspring stock and see if I have one. I need a SA705, which is the same as the Waltham number 2205. Good, I have a half a dozen for this watch. It's a nice Swiss-made mainspring. It's a modern spring made from what is called white metal. I believe it's an alloy of stainless steel and is considered unbreakable as compared to the high-carbon blue steel mainsprings. Get this back in the watch and see how it performs. It's winding up nicely. Now the balance assembly, and it's taken off and running just fine. Balance has very good motion. The second hand has plenty of clearance now. The hands need to be adjusted so as to not interfere with each other. Get it fitted back into the case and see how it does. In the last couple of years, there's been concern about polishing these vintage watch cases. This one has some tarnish, and buffing could bring it to a mere finish. The drawback is buffing softens the sharp edges, and after several buffings, a lot of detail ends up getting lost. Unless the customer requests polishing and buffing, I leave these cases untouched.